Okay, Assalamualaikum and good day. Again, we will continue for our last chapter, which is column. So, from this column, you can download these notes from a description below. So, you can write any notes on that. Okay, what is column? Column is a long slender members subjected to an axial loading axial compressive force. Okay, how to know that that column is a long or short members? Okay, for example, when the column is applied the axial compressive force, so like this, if the failure of this column is due to crushing, so this is we call as short column. However, if the axial compressive on that column, the column itself is not crushing but it will buckling, so that's we call as long slender members. There are classified into two types of loading, which is centric loading and eccentric loading. For centric loading, it shows that when the force P applied on the column directly on the centroid. Okay, for eccentric loading, this force is not parallel to the centroid, but it have another distance. For example, force would be here. Okay, they have another distance to centroid. Okay, this is for eccentric loading. However, for the first case, refer to the Euler formula, we just focus on the centric loading. Okay, refer to this figure. Okay, it shows that one column and then it exerted on one axial compressive force, and we call it as P critical force. Okay, when the force itself will increase to the when P more than P critical, so this column will be buckled. So the equation for P critical will be given in this formula, pi square EI over L square. So when P divided by A, so we get the critical stress equal to pi square E over L over R square. So this ratio is given as slenderness ratio. We call this is slenderness ratio. Okay, how to derive from force critical to the critical stress? So I'll show you like this. So when P equal to pi square EI over L square. So when we divide by A to get equal stress, so all of this equation will be divided by A. So we get like this, pi square E I will be substitute to A R square. Okay, and divide by L square A. So from this equation, so we can cut this A, so we get pi square E R square over L square. So finally we get pi square E over L over R square. So this is critical stress for this equation. Okay, pi square E over L R square. From this column, okay, this L is not represent the whole length of column L, not like that. It depends on 4 factors. Okay, L, this is a LE. LE is referred to the equivalent length. It depends on 4 criteria. Okay, 1, 2, 3, 4. For example, the fixed ends, the L equivalent length equal to 0.5 times L. And so the K coefficient of these fixed ends equal to 0.5. So you will get this KL. K refer to 0.5. This is for fixed end. Means that on the top you get fixed and the bottom also fixed. However, for example, in pin fixed, this is pin and this is fixed. So the K equivalent to 0.7. So 0.7 times L. L is the total length of column. So equivalent length equal to 0.7 L. What happened to the pin ends? This is pin and this is pin. So K equal to 1. So the equivalent length equal to the total length of column. And finally, for fixed and free ends, this is free ends. Okay, this is fixed. So the K equal to 2L. K equal to 2. So the equivalent length equal to 2L. So from that, the first equation, okay, we have a critical force and critical stress. So L here is referred to the LE. This is LE. Okay, so pi square E over LE divided by R square. Okay, and LE is depends on the 4 criteria: fixed ends, pin ends, fixed and pin ends, the fixed and free ends. So as I mentioned just now, when a P is not parallel to the centroid, so what happened? This is what we call as eccentric loading. Eccentric loading. Okay, when the P is not parallel to the centroid. So this is centric. Okay, eccentric is become after the P have a slightly to the left or to the right. So they have a distance between the centroid line and the force itself. This is P. So this distance we call as E. Okay, it's referred to E. E is distance from the center to the P. Okay, this is eccentric loading. For eccentric loading, we cannot use the Euler formula. So they have another formula which is second formula. Second formula should be like this: stress maximum equal to yield stress equal to P over A and so on. So you have to remember, you have to memorize this equation. Okay, this equation is very important for eccentric loading. So make sure this eccentric loading you know every terms, okay, in this equation. LE, what is R, EAP, and so on. Alright, so clear for this column topics. Okay, this is only the formula that you need to know and you need to remember. You need to memorize all the equation. Okay, for example, the first equation, this, second, this, and finally for the second formula in eccentric loading is this. So finish for this chapter. So after this, I will show you how to solve any problems related to this column topics. So thank you and see you again for the next video. Thank you.